in software testing and quality analysis, we are going to test these three functionalities, namely webmail, intranet, and discussions. So I'll give you a brief overview of how these three functionalities are working. First of all, let's talk about webmail. The current application webmail is provided by Zebra, and the Zebra collaboration suite provides us with two APIs. These APIs are get inbox and get email. Now, to use these APIs, we need the credentials of the user, which are the user ID and password. So what we are going to test is, we'll test the get inbox API, and if it returns the correct output, the output should be a JSON object which will have a list of all the emails in this user's inbox. So if the inbox is returning the correct items, then we'll consider that this test case passes. And for the second API, which is get email, we'll use every inbox item is having a particular ID, and this ID can then be used with get email to get the email from Zebra. So the command basically would be to do http webmail.daict.ac.in/the ID. Now this ID tells the Zebra server that I am looking for this particular email having this ID. So when this email is returned, I can again write another test case to check if the email is correctly returned. So this is the functionality of the webmail module. Right. So the next module we are going to discuss would be intranet. The intranet module works by basically this mechanism. Let's suppose we have a computer which is inside the campus. This is the campus boundary. Now the problem with intranet in particular is that a user outside the campus cannot access the intranet, but a user inside the campus can access it due to some firewall rules. So what we have done for this functionality in our Send project is that we have used a computer which will always stay on, and this computer will upload the files to the cloud. This cloud is an abstraction for our server, and then from the cloud we can then access the intranet from anywhere in the world. So this is the basic flow of how the intranet module is working. So from the testing point of view, we want to test that if this asynchronous API is working correctly. Now, as we know what asynchronous is, now I think let's further dive into what asynchronous requests are, as they are very important from the testing point of view, because these requests are which return at an let's say unpredictable rate. Like there is no particular time in which they'll return the result. Let's say it returns an average response time of 2 to 3 seconds. It can also go to 11 seconds, or it can be blazingly fast in 200 milliseconds. So as you can see, the asynchronous requests are unpredictable, but they always result in the same output. The output would be, let's suppose for intranet, we would want the folder tree to be returned. The folder tree is the directory tree as in Unix. So we want to test if the folder tree is returned correctly every time we call the intranet server. To test that, we will be using Mocha and try to make assertions. But to mock an async request, we'll be also using nuke. Now what nuke does is, it mocks the asynchronous request. I don't want to wait every time 2 to 3 seconds or 11 seconds after every test run. So what nuke will do is, it will mock the asynchronous request and make the asynchronous request predictable, and hence we can test the asynchronous in a predictable and synchronous fashion. So the next module which we'll be discussing is discussions. So in discussions, we are trying to implement a chatting functionality. We are trying to focus on two particular type of groups, which are a batch in DICT and DICT in general. So what this discussions feature would be doing is, it will allow a user to communicate within his batch with his batchmates, and in the DICT feature, he'll be able to broadcast his message to the entire college. Let's assume that this is our college. So he can broadcast his message to the entire student body, and in this case he can only focus on the batch. So this is the discussion module, and if you want to test the discussion module, we'll be having two scenarios. The first scenario would be to test the batch functionality. That is, if a user sends a message to the batch and another user who happens to be in his batch should get the message. Let's say this is student 1. Let's say this is our user which we are targeting. And if he broadcasts a message in the batch channel, the student 1 who happens to be in his batch should get the message, and the student who happens to be his senior should not get the message. But in the case of the DICT channel, everyone should get the message and everyone should be able to exchange the conversation. So this would be the testing scenario of this particular feature. कितने में लगा?
Now this is the login. It's going to grab some vadas from Padma Kamal. This is the internet. Here we go to academic page. And then you can go to a professor's lecture folder. You can star. Now it will appear on your dashboard. You can message the professor. And then here's the webmail, the list of all the emails. Let's go back. Here you can enter your to-do list. This is the batch chat. You can enter a message and it will be broadcasted to the entire batch. And you can also upload a file from here. That's it. Let's log out. Here you can also see your profile. That's it. and you can choose the widgets whichever you want. And let's see.
In this module, we'll be discussing the testing libraries we have used for this presentation. The first library which we'll be discussing is Mocha.js. Now, Mocha.js is a test runner which allows us to run the test cases in a directory. So suppose I have a folder of my application called app, and in this I have a directory called test. And in this directory, all the test cases are lined. Suppose x.test.js, y.test.js, and so on. So suppose I want to run these test cases, I will type in my command line mocha app/test. This will tell the Mocha library that I want to test my test cases which are lying in this directory and run the test cases. Now Mocha can provide you with two functionalities. Either the first one is to run the test cases once, and the second option is to run the test cases as you code. That means that suppose I am coding something and the test cases would be running in the background simultaneously. And if a test case fails, I'll get notified. That is watch app.test. Now this functionality of Mocha is constantly watching the app/test folder for any changes. The moment any change occurs, the test cases are run again, and I am notified with the test result, which will say suppose 27 out of 28 are passing. That means that one test case failed while I was coding the current module. Now going in depth with Mocha.js, we have these two functions which are describe and it. These two functions are what Mocha.js is providing us. The describe function tells us to describe a test module. Suppose I want to test the module called chat application. So I write describe chat test cases. This helps me to group the test cases in one module. And then I'll write a function. And inside this function would be my test cases. So this is a way of organizing the test cases into groups of or chunks of describe functions. So when my test case runs, I'll be given with a chat test cases bullet point, and inside these chat test cases, I'll be shown with the number of test cases inside that describe block. So that helps me organize my test cases. The next function which we'll be discussing is it. The it function describes a single unit test case. The syntax for it is like this. And there, inside this, I can describe this test case. Let's say testing the nav bar. So this single test case tells me that it is testing the nav bar, and inside this, I can write the logic for this test case. And then Mocha would run this test case, and it will tell if this test case passes or fails.
Hi, we'll be talking about Mocha.js today, and this is the introduction for Mocha. Uh, Mocha is a feature-rich JavaScript test framework which runs on Node.js and in the browser, making asynchronous testing simple and fun. Mocha tests run serially, allowing for flexible and accurate reporting while mapping uncaught exceptions to the correct test cases. Uh, you can see the features for Mocha.js are given here. It runs on Node and browser, simplifies asynchronous testing, growl notifications, and you can choose your own assertion library. There are a few more features here. It reports test durations. It can highlight slow tests, file watcher support, and node debugger support as well. This is the basic TDD workflow. Here you write a test case for a desired software feature and you watch it fail because of course you haven't coded it yet. Then you implement the feature. Then it might fail again because the code might have some flaws. Then you fix the syntax, logic, and then you watch the test case pass, and then you can feel accomplished about it. This is the syntax that Mocha expects. You describe some features, describe when something is given, what the code should do. You write the assertions, and that's how it runs. Now this is an asynchronous code. Testing asynchronous code with Mocha is very simple. You simply invoke the callback when your test is complete by adding a callback to it function. Mocha will know that it should wait for completion. These are the assertions: should, expect, and better assert. How to start? So you need Node.js and you need Mocha, and in the next part of the video, we'll show how to install Mocha on your computer. This is the video that explains how to install Mocha on your computer. You can see on the website the list of commands that you need to install. First, you type npm install -g Mocha, and that G stands for global here. And now it's installing. It's as you can.
Okay, so in this module, we'll be discussing Chai.js. Chai.js is an assertion library in JavaScript. Chai.js provides us with three assertion types, which are should, expect, and assert. Now, according to documentation, should and expect belong to the category of BDD type of testing, and assert belongs to the category of TDD type of testing. Now, what BDD is basically behavior driven development. Behavior driven development forces you to basically first write the behavior or the functionality and then write the test cases according to the Chai.js documentation. And in TDD, you are forced to write the test cases first and make them fail, and then write the code and then see them pass the test cases. Write test cases first and then write the code. So Chai.js gives you the function called assert to be used with the TDD style of development, and should and expect with the BDD type of testing. Now let's focus on what assert is. I'll give you an example of assert. Let's suppose we want to assert type of, let's say, variable foo to be a string. Now what this test case is doing is it's asserting that the type of foo should be string. Let's say we define foo as a string. Hello. So this is how you'll assert in a BDD style of testing. Now you can also see in the documentation of Chai.js that there are many other APIs for testing with assert. Let's say assert.equal. where you can test two functions. Foo should be equal to hello. Or there's this another API assert dot length of foo to be equal to 7. So in this case the test case might fail, and in this case the test case might assert correctly. So this was assertion in TDD style of development. Now let's focus on BDD style of development, which gives you two functionalities called should and expect.
The official website of Chai.js. So Mocha is a JavaScript test framework and Chai is a BDD/TDD assertion library. Both Mocha and Chai run in node environments or in the browser. So TDD and BDD basically stand for test-driven development and behavior-driven development respectively. So TDD is an approach to writing software where you write test cases before you write the application code. So the basic steps in TDD are you write the test case and make sure it fails. You write the simplest, easiest possible code to make the test pass, and you optimize or simplify the application code, making sure that all the tests still pass. So that was TDD in a nutshell. So now I'll talk about BDD. BDD is meant to eliminate issues that TDD might cause. In contrast to TDD, BDD is when we write behavior and specification that then drives our software development. Behavior and specification might seem similar to tests, but the difference is very subtle and important. The ability to read your test like a sentence is cognitive shift in how will you think about your test. In BDD, we basically write our test cases just as we talk in normal life. And in Chai, there are basically three assertions possible. There are should, expect, and assert. And if you go in the API, there you go. The expect and should API covers the BDD assertion styles, and the assert API covers the TDD assertion style. Okay, so now that we know what Chai is, so now we'll go and install Chai. So installation is pretty simple. You just need to put this command npm install Chai. So you go to terminal and put this, and it will work on its own. It's installing right now. So installation depends on your internet speed, and there you go. Chai has been successfully installed in this computer. Thanks.
So we'll be testing should in this module. What should does is it helps you test in a BDD style of development. Let's say we have a variable foo, which is equal to hello. Now we can test foo or assert on foo using this syntax. Foo should be string. So in this assertion, you can see that we are asserting using a BDD style of development, and it says, it seems like a simple English sentence like foo should be string. And suppose I want to test the length of the string. Foo should be, sorry, foo should have length 3. As you can see that in BDD we are basically writing plain English sentences, and it helps us in asserting certain functions or certain variables. So now we are at the last module of our presentation, which is testing a 5,000 lines of code. As you know, we have decided to test DA dash, which is approximately 6.2k lines of code and has 78 test cases and it has a coverage of 69.2%. This is what we'll be testing in the subsequent videos. Testing, we are going to show you the source code of the DA dash. As you can see, there's a test folder which is read by the Mocha.js application. This is the command line scripts which the Mocha.js would be reading. The first one is to tell the Mocha.js where the test cases are. As you can see that it tells that the setup.js file is at this location. All the test cases are at this location. And to use the Babel core compiler. Now when we look at our test case directory, it is having 3 folders which are divided on the basis of their logical functionality. So there are 3 folders, namely components, Redux and widgets, and then there is this setup file. The setup file tells the Mocha to initialize certain variables, expose certain properties, and create a virtual DOM for the test cases. The virtual DOM is provided by a JS DOM library, as you can see here. The next folder which we'll be talking about is the components, and in this we are testing the home component and the navbar component. You can look at this test case first, which is saying clicking overlay should change the application state. So what we are doing is we are basically mounting the home component, and then we are asserting that wrapper.find overlay should simulate a click. So we are simulating a click and finding overlay. So what this means is we'll find the overlay class and we'll simulate a click, and then we are calling the expect library to expect a certain thing. In this case, we'll be expecting wrapper.state.sidebar open to be equal to true, which means that the sidebar should be open when we simulate a click. And the second test case is to check if the wrapper is closing the sidebar. So if you simulate the click again, it should toggle the sidebar and it should close the overlay. And if we run this test case, which can be done by it.only, which means that I only want to run this test case, and then I'll write npm test. As you can see that I am getting one passing. These are these warnings which the Mocha.js warns you, but these are none of our concern because we are focusing on the testing part of the application. So as you can see that the clicking overlay should change state is passing. Next, we can look at the Redux test cases. Redux is a library which we are using for our application architecture, and the internal working of Redux is not important from testing point of view. So let's look at let's say intranet action test cases. As I discussed, here is the knock library which mocks the asynchronous network request, and then there is this expect from chai, as we discussed in our previous module, that expect allows us to do TDD type of development. And this is our block of describe. This describes basically the asynchronous intranet actions, and it tells us that after each test case, the knock should clean all the variables. So after each test case, knock will clean all the variables which it has initialized. The first test case is to get the intranet. Now this is the API which is going to be mocked by knock, and this API is from a server called bangle.io/API/intranet, and then I am mocking the reply to be like this. This is a JSON object which will reply 200 and this object. So what knock will do is it will basically fake the network request and make it synchronous. So I am basically knocking the request, and whenever my store is asking for the API, it just gets this result, and then I can expect it to be equal to expected actions over here. So this is how an asynchronous API is mocked. Going further into details of the actions, what is happening is that I am basically telling Mocha that these are the expected actions that should be returned by the unit that is being tested. and these are all the stubs which are being used so that our application can run. And this is the actual function which will run the test case. Now here I am calling this function action.getIntranet, which is my unit test case main function, which will get the intranet. And since it is an asynchronous function, the reply can be after a certain interval of time, which can be random in this case. So when .then means that the API has returned the result. And when .then is called, I am expecting that the store.get actions should be deeply equal to the expected actions that I have described in line number 24 to 29. And once it is done, my test case passes. Let us test this test case. It dot only. As you can see, this test case passes, and if I change the output of the knock request, you can see that the test case might fail. Suppose I do academics, lecture, and Ashwin Kirtan. Since I have changed the mocked API, the result might not be the same, and our test case should fail. As you can see, our test case has failed, and it tells us where it has failed exactly. So it says that academic folder should be academic, and there is no entry called Ashwin Kirtane in the expected output. So this is how a test case fails in an asynchronous environment. Now let us look at other test cases. Let's call for widgets. In widgets, this is a huge test case, and it is requiring a lot of boilerplate to get the test cases running. We are using Sinon to simulate or mock certain functions. Sinon.spy helps us to mock a function. Let's check out this test case. In this test case, we are basically asking that the intranet component should mount when the code is run. So this is the variable where we are going to test which component should be mounted, and then foo contains the intranet widget mounted, and then we are expecting that foo.getIntranet called once to equal to true. So the function to give, which is this function should have getIntranet, and this getIntranet function should be called only once, and this is what we are expecting in this test case. So when we write expect func to give getIntranet dot called once, means that the test case is checking if the function is being called once and only once. Let's test this test case. As you can see that the function was called only once, and hence it is passing. Suppose we change our test case code, which is the intranet widget, and if I go to my intranet widget test code, and if I wanted to call twice, our test case should fail. So if I go to intranet widget, and the function that we are testing is getIntranet, and suppose if I call getIntranet twice, here is a function which is being called, and suppose I call it twice, our test case should fail. As you can see, the test case has decided or seen that the test case is actually being called twice, and hence the test case is being reported as a failed test case. Now let's change it back to normal and call it once. The test case would pass. This is how we can test if a function is being called twice, thrice, or only once. Let's call it twice again, and let's make it pass the test case called twice. So if we change it to called twice, the test case should pass. and as expected the test case is passing. So this is how we can test a mocked function if it is being called twice or thrice. Now, so in this phase we'll be testing the entire application as we discussed before. So we can run the test case by typing npm run test, and then it will run the entire test cases found in the test folder. As you can see, the test cases are running. These are the describe blocks, and these are the test cases inside each block, and these are the warnings. And as you can see, all the 45 test cases are passing. The rest of the test cases are functional and are covered in our documentation. Thank you for watching. We hope we could share some testing knowledge from our side.